Hello, I'm Yusuf. I'm the only person in Chicken Coup. I implemented all effective addressing modes and all opcodes. To the best of my knowledge, haven't found any bugs in them yet. But this is a software project, so there may be bugs that I'm not aware of. My design uses the concept of signatures. I define signatures as the bit permutations that that distinguish between one opcode from another. So the signature for RTS is different from the signature for JSON, and they should not overlap. Using these signatures, then my program is simply a big while loop. I get the word and I compare it with the NOP signature. If it is the NOP, then I call NOP routine. If it is not, then I go ahead and compare it with move. If it's move, then I call move routine, and so on and so forth until I check all opcodes. If it doesn't match with any opcode, then I call the data routine. I use test-driven development. I would write tests, run the tests, make sure that they fail, implement my feature, make sure that the test succeeds after I implement the feature, and clean up the code a little bit. I write all my code in small letters, but I write all my labels in capital letters. When I have a label inside a subroutine, I prepend the subroutine name to that label. So if I have a loop inside move routine, I call that loop move routine loop. This allows me to avoid clashes with another loop, for example, in the main loop that is simply called loop. And this saved me a lot of time and the headache of worrying if I used that label before or not. Okay, my to-do list is to review move and BCC. After that, I would be finished with the coding part. And then I need to clean up the report, and if I have time, I intend to add a table of signatures, but apparently this is not required, so I'm not sure I will do it. At the beginning, I had problems with load effective address. I would load effective address, I would load a string into A1, print that string, that works fine, then read input into A1, and then print a string, try to print a string again, I would find that my string has been modified. And I learned that A1 is really just a pointer to that string, so I outright modified my string. When I learned that, that made me think that I can use that in my program. So I have A1 always pointing to a buffer, and that I'm going to print to, and instead of printing directly to the output, no, I print to that buffer. I load effective address, the string that I want to print into A2, and then I copy byte by byte from A2 to A1. That way I can have at the end one good buffer to give to print at once. I faced the problem with bro and BCC that the professor mentioned in class. And the last thing is jump. I use jump tables. If you look at the appendix, you will find that they assume that jump tables is 6 bytes long, so 3 words. But I found that if you jump down, this is always true. But if you jump to code that was written previously, so if you jump up, a few lines or something, then jump might be 2 words. And that means that if you jump down, it's always 3 words, but if you jump up, it might be 2 words. And that means if you jump up in your table is all messed up, the alignment is off, and your table is broken. This is really dangerous. I think, when I talked to the professor, he said that it probably is an assembler bug. Yeah, and I'm happy I noticed that. Thank you very much for listening, and yeah, let's have a look at the demonstration.